In question 54, a roller is made by joining together two cones at their velocities O. It is kept on two rails AB and CD which are placed asymmetrically with its axis perpendicular to CD and its center O at the center of the line joining AB and CD is CP. So what we have to find out, if we are given two rows, first of all we will consider cone, two cones like that. They are the axis, symmetrical axis is this. Yeah. And we are providing certain velocity, that is point O. Okay. There are two rails. We can say there are two rails. Sorry. One is like that, on which it is, and another is just this one. Now we have to find when it is just rolling. Okay, it is just rolling, or we can say it's rolling omega. Okay, and same omega. If we consider a particle or point of contact, so we identify in which direction we move. We know that tangential velocity of the particle that is in contact like this. Although the distance is r2 and we can say this distance is r1. When we know that after a certain time it will reach over here and it will reach over here. So this distance is getting, we can say, decreases. Like it is r2 dash and it is r1 dash. So we know that when we want to know tangential velocity, or like that means in which direction they will go. It is given angular velocity of A will be equal to angular velocity of V, that is VTA upon RA, so it will be VTV upon RB. But we are given after a certain time when they will reach over here, we can also calculate this question on the basis of torque. So R2 will be less than R1, or we can say RB means this R2. Okay, or we can say 1 upon 1 or 2 upon 2. So means it is given R2 upon R1, that is equal to V1 upon V2. So what, as R2 is R1 upon R2 upon R1 is less than 1. So we can say this quantity is less than 1. So what we can say, less than 1. So V2 is greater than V1. Means tangential velocity of any particle or that is in contact with the ground or with the rails. So what, this would move with a faster. That's why it would like to turn in the leftward rather than rightward, because whenever there is a point of contact, if it is having more velocity of tangent, that's why the movement will be quite faster. That meets it with the option 2. That's why it will turn left. Option 2 is the right choice. Now question 55. In question 55, a pendulum clock loses 12 seconds a day if the temperature is 40 degrees Celsius and gains 4 seconds a day. If the temperature is 20 degrees Celsius, the temperature at which the clock will show correct time and the coefficient of linear expansion of the metal of the pendulum shaft accurately. So this question is directly taken from the linear expansion part, very basic questions. Question 55. So we know that in the time period T is equal to 2 pi under root L upon G. So when we want to find out the relative change in time period or increase of temperature, so this is what 1 upon 2 delta L by L. Usually in thermal expansion, delta L is equal to upon L is equal to alpha into this rise in temperature. Okay, so we can say that delta T by T is equal to 1 by 2 into alpha T final minus T initial, right? Or we can say temperature final minus temperature initial. Two conditions are given, 14 12. So 40 minus 12. So delta T is given, that is 12 seconds upon T, that is 1 by 2. Coefficient of expansion is given, that is alpha. So first condition is what? That is 40 minus theta. Equation number 1. Second, it gains 4 seconds a day upon T, that is 1 by 2. Alpha, that is when it loses this much. It loses, that is theta minus 20, equation number 2. Usually we are getting this one. When we divide equation 1 by equation 2, solving this, we are getting the value of theta would be around 24.5 degrees Celsius. Now on the basis of this, when we put this value over here in any one of the equation, usually, because two equation, two unknown. So finally we will get the value of alpha will be around, that is 1.85 into 10 to the power minus of 15 per degree Celsius. And that match with the option 2 over here. So this question was directly based on the linear expansion, in which time period is affected by the change in temperature. Time period of a simple pendulum of length. So this was an easy one. Now we would like to discuss next question, that is question number 56. In question 56 we are given, let's start question 56. In question 56, a uniform string of length 20 meter is suspended from the rigid support. A short wave pulse is introduced at its lower end. It starts moving up the string. The time taken to reach the support. Very easy question taken from the wave propagation. क्या है कि जब भी कोई ट्रांसवर्स वेव मूव करती है, कि कोई भी मैं इजी लेता हूँ यहाँ पे, किसी एक मोमेंट पे ये मोमेंट है, माना इसकी लेंथ है l, हम लोग जानते हैं कि वेलोसिटी कैलकुलेटेड, स्पीड कैलकुलेटेड, दैट इज इक्वल टू टेंशन अपॉन मास पर यूनिट। अब जैसे जैसे डिफरेंट पॉइंट पे मैं टेंशन गेन करता जा रहा हूँ, टेंशन बढ़ती जाएगी क्योंकि वेट इंक्रीज होता जा रहा है। नाउ किसी एक डिस्टेंस x पे I want to calculate the speed of the particle over here that is propagating or forward with the velocity. Okay, सीधी सी बात है, velocity of this particle is just a function of tension. और tension कैसे निकालेंगे? Because if you consider it a mass element, so mass element is just dm. Now we want to calculate tension due to that. Okay, dt, so that is equal to dmg. So what dmg is what? That is equal to total mass upon total length and the x at which we want to know into g. Okay, so this is what mlx into dx. M by L into dx in this one. So when we want to know how to calculate velocity at that point, that is equal to Vp, velocity at point P, that is equal to under root of mass per L into g into dx divided by under root, okay, divided by mass per unit m. Solving this one, we were getting under root of g into x because we consider a small elements, that is equal to this. Okay, so now we want to find out, as it is propagating vertically upward from length 0 to L. So we want to find out the time required to move just from point lower point to upper end. So easily we can propagate, time is equal to the distance upon total area. So we can calculate this like dx upon dt. This is what the velocity, that is equal to under root of g into x. So we can say 1 upon under root of gx into dx, that is equal to dt, and length is just from 0 to 20 meter. It is given in the question. So when we will 0 to time t, when we will solving this one, we will get time would be around t is equal to 2 root 2 second. Hence option 4 is the correct choice. Now we will switch to the next question. That is question number 57. In question 57, it is easy one. A point particle of mass m moves along the uniformly rough track PQ as on the figure. The coefficient of friction between the particles and the rough track equal is mu. The particle is released from the rest from the point P and it comes to rest at a point R. Now the energy is lost by the ball over the parts PQ and PR of the track are equal to each other, and no energy is lost when particle changes direction from P2 to QR. The value of the coefficient of friction mu and the distance x. Easy one. This question is from work energy power. Energy lost across the frictional surface. Frictional surface. Now we are given point P, Q and R. It is given that this distance is just, this height is h is equal to 2 meter, this is 4 meter, and this is equal to x. Q to R. So what? Energy lost across path PQ. Energy lost across PQ, this point, right? That is mu mgx we can calculate. That is, if this angle is theta, mu, because if particle is there, there is a normal action. Fs into d, Fs equal to mu into mg into cos of theta, mu mg cos theta into the distance. Substituting the corresponding values, we are getting that is equal to mu m into g into cos of theta into 4. Now, energy lost across path QR, that is equal to mu mg, the distance, that is x. Simply equation 1 and equation 2. Now it is given in the question that, and it is same. So mu mg x is equal to mu mg cos of theta into 4. Solving this one, we are getting x is equal to 2 root 3. Okay, so that is equal to 3.45. I am having mathematical equations written, that's why I am writing here. So on the basis of that, if you want to find out the, okay, there another data is given to find out for me. Because first part is over, second to find out the coefficient of friction is given that it is just half of that. Means energy lost across this path will be, it is just half of the energy from P to P if it is smooth. So that is mu of m into g into x, that is equal to mgh by 2. Just substituting the values. Okay, so mu into is equal to h by 2 into x, substituting the value, mu is equal to h is 2 upon 2 into 3.45. Solving this, we are getting that is 0.29. Hence both the options match with the option 4. So this was an easy question directly taken from laws of motion and work energy power. After this, we would like to discuss next question, that is question number 58. Question 58, simple question taken from the sound mechanics. That is, a pipe open at both ends has fundamental frequency f in the air. The pipe is dipped vertically in water so that half of it is in water. The fundamental frequency of the air column is now. First case, when it is in open. When this pipe is open. Okay, the fundamental frequency. This is what must first power down, you can say. So what? This length is L and that is equal to lambda by 2. So lambda is equal to L by, okay, that is twice of L. We want to get the frequency. Frequency is equal to V by L, V by lambda, so V by 2L. First part. If we dip this in water, what happens? This will behave as an open pipe or closed pipe. Close it. So this is what water. So less. So this part is actually lambda by 4, that is equal to initial length was L, it will become L by 2. So we are getting lambda is again twice of L. So we can get F is equal to V by lambda, that is V by 2L. No change in frequency. So open is equal to F closed. That match with the option 1. Easiest question or easy question in JEE. Now question 59. In question 59 it is given a particle performs simple harmonic motion with the amplitude A. Its speed is traveled at the instant that it is at a distance 2a by 3 from the equivalent position. The new amplitude of the motion is. So this question is taken from SHM, simple harmonic motion, where we get the velocity is equal to omega a square minus x square. X is the displacement at any time t. Now we can say that a particle is performs simple harmonic motion, okay, amplitude A. Its speed is traveled at a distance that its distance is 2a by 3, and this is equal to 2a by 3. This velocity get traveled. So we can say first equation is v equal to omega under root of a square minus x square. It is traveled 3v, that is equal to omega under root of a square minus 2a by 3 whole square. Equation 2. Solve these, equation 1 by equation 2, solving the value of x or this switch. Okay, so we will get this, just x will be equal to 7a by 3. That match with the option 1. So this was question number 59. Now similarly question 60. An arc lamp requires a direct current of 10 ampere at a 80 volt to junction. If it is connected to 220 volt, now connected to AC having frequency 50 Hz, the series inductor needed for it to work. Initially there is a DC connection. Okay, I mean there is a DC power connected across a resistance. We will get the value of resistance R. Now you connect this resistance with an inductor in series. So what? That is R is, this question is from AC part. Don't mix concept of DC and AC, that is R upon V upon I. So V, Ohm's law, V is equal to 80 volt upon 10 ampere. So it is equal to 8 ohm. Part 1. Now we are connecting, it is connected to a 220 volt. So simply you are getting current of 10. Okay, this one. I is equal to 10, V is equal to 80. So we got this much value. So now if they connected to 220 volt resistance, we have done the series conductor to work close to it. Okay, now we want to get the same value of current I, that is equal to V upon Z, VRMS. So VRMS is what actually, that is 220 upon under root of resistance R square plus inducting coil XL square is equal to 10 ampere. So R is given as how much? 8 ohm. So we in this way we will get the value of XL. XL is equal to 2 omega into L, that is 2 pi into frequency into L. So we are given L is equal to XL upon 2 pi into frequency. Frequency is 50, 3.14. Okay, and XL we can calculate it from this part. So we will get L will be equal to 0.065 Henry. So we got this paper was quite easy comparatively to 2015 physics section. Usually the very less stress on magnetism, but very much intensifying stress on this one, semiconductor devices. There was only one question from optics part, or two easy questions from the modern physics, and easy questions from the there were two questions from the errors and measurement as usual. Last year they asked one question, this year they asked two questions. So we got this question was irregular actually. We called it as irregular paper usually, because last year the weightage of magnetism was 17%. This year was only just we can say 5%. Okay, so it was an easy paper. Definitely cutoff will down. Cutoff will rise approximately 110, 111 approximately. But in physics we can approx at least 12 marks or 13 marks. Like that. Thank you.